In this video, we are going to be talking about limits in calculus. But first, before getting to the definition of a limit, let's work through a real-life world example of what could be a limit. Let's say that this is you. Okay, so you're walking up this bridge. Right? But then all of a sudden, you see that there is a crack in the bridge. Now, how do you cross it? Well, you can't. As you can see, if you would cross it, you'd fall. But we can infinitely approach that crack. So you can get infinitely close to the crack in between the two sections of the bridge, but you can never actually cross that crack. So mathematically, we'd call that a limit. So this is the limit. This line that I'm drawing, that is the limit. You cannot cross that line, otherwise you would fall in between the bridge. So that is what a limit is. But now let's get to the definition. A limit is the value a function approaches as the input approaches a specific number, regardless of whether the function actually reaches that value at that point. Okay, well, if that is a limit, let's look at it from a mathematical perspective. This isn't the perfect graph I drew, but it's good enough. So this is a graph of x squared minus 4 over x minus 2. And this is the limit notation. X and then arrow sign to 2 means if the value of x infinitely approaches 0, what value is the limit? So this is the graph of x squared minus 4 over x minus 2. And as you can see, we have a point of discontinuity here. Right, so this point of discontinuity, there is nothing there. So what does it mean when it say the limit as x approaches 2? Well, in calculus, we would say that the limit is actually just 4. But there is a very good reason on why it's 4. Let's say I plug in the value of a number that is very, very close to 2. So 1.9999 squared minus 4 over 1.9999 minus 2. So I'm plugging this into my calculator right now. And as you can see, if we plug in the value, it would equal 3.99999. So that gets very, very close to 4. So imagine what would happen if we put, let's say, 10 more extra zeros. I mean, not zeros, 9. So I'm actually going to do just that. How many did I just put? 1, 2, 3, 4, 5, 6. So the same question, we got very, very close there, right? So let's say we add 5 more 9s. So we have 10 9s there. So I recommend for you to plug this into your calculator and see what value you get. Personally, I have the Casio FX991ES Plus, and when I plugged that into my calculator, it just gave me an answer of 4. So that just goes to show eventually when you put in a number that is so close, the difference is so negligible that we can just round it up to just 4, or what we would call the limit. So what is the limit as x approaches 2 of x squared minus 4 over x minus 2? Well, the limit there is 4. And if you still don't believe me, if we infinitely approach this, we will still get this value at 4. So that's what a limit is. A limit is the value of a function that approaches the input as approaches a specific number, regardless of whether the function actually reaches that value at that point. It doesn't matter if it has to reach that point. It's the limit. It will infinitely approach the point. Another thing to note that a limit in calculus is basically like the most integral part of calculus, right? You can't have integrals or derivatives without limits. You need limits in calculus. So without limits, calculus would probably never be a thing. And for my third example of a limit, I'm going to be doing a series. So hopefully you know what a convergent series is, right? So let's say we have are adding, we have a value of 1 plus 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32 plus 1 over 64 plus 1 over 128 plus 1 over 256. So we infinitely divide these numbers by half. Okay? So if we infinitely add these numbers, it wouldn't equal infinity. I think it's very obvious. Like, if we add up whole numbers like 1 plus 2 plus 3, or we're talking about geometric sequences. So 1 plus 2 plus 4 plus 8 plus 16. And double these numbers, it would equal infinity, right? But this gets smaller and smaller. So it wouldn't reach infinity. It would reach a number, and that's the number we would call the limit. Now, for this for this series, the infinitely converging in a half series, we use the sum formula of a1 over 1 minus r, and basically it's 1 over 1 minus 1/2. So if we do that, we get that if we infinitely add these, we'd get a value of 2. So 2 is the limit. So it's going to infinitely add up, but it is never going to reach 2. But eventually, the difference between 2 and the infinitely small difference between 2 is going to be so negligible that we can just say that when we add all these numbers up, we can just say that it is 2. So that is my third example on what a limit is. So Now hopefully you understand what a limit is. Now that we know what a limit is, let's do some questions related to limits. First, I'm going to move all of this over here. Hang on, I've got to move Timmy over here. Okay. So, let's get to our first limit question. The limit, what is the limit? So this is probably going to be a very easy question to start off with. What is the limit as x goes to 3 of 2x squared minus 5x plus 1? Take like a minute and solve this question. Pause the video. Okay, so if you got an answer of 4, that is the correct answer. Now, you might be thinking, well, there is no point of discontinuity or any break in the graph. But you don't actually need a break in the graph for a limit. A limit can be any point on the graph. So let's go back to our original thing. The limit as we can, if we erase this question and say what is the limit as x approaches 1, then we could look at the graph and see, oh, it approaches 3. So our answer would just be 3. So the limit doesn't necessarily apply just for breaks. It could apply to any point. So if you know about polynomials, since polynomials are continuous, we can just substitute the value of x equals 3. So substituting that value in, we'd get so this equals 4. The limit as x approaches 3 of 2x squared minus 5x plus 1 is 4. Okay, so let's get to the next question. So I'm assuming if you're taking calculus at this point, you probably know how to factor things. So I'm probably gonna skip over the easier ones. So let's do, I'm thinking of a question. Oh, what is the limit as x approaches 9 of the function the square root of x minus 3 over x minus 9? Pause the video and solve that question. Okay, hopefully you've done that question. So let's get started. First, oh sorry, this should be a 9. Okay, so hopefully you've done that question, and let's get started. So first, we always want to test out if we can just substitute, because in the test, you always want to do that, because, you know, if you make a mistake in your factoring and you realize, oh, I could have just substituted in and we would have found out the limit. It would have saved you a bunch of time. So just plug in the value, and if we plug in 9 to the equation, we see that we get 0 over 0. Not 0. 0 over 0. So we can't do that because 0 over 0 is undefined. So we need to simplify this. And if you learned Algebra 2 in pre-calc, you know that all you have to do is multiply by the conjugate. So on the top, I'm doing this in red. So on the top, I multiply by square root of x the square root of x plus 3, and on the bottom I multiply by the square root of x plus 3. So if you multiply that, the square roots on the top would cancel out. So you'd get x minus 9 over x minus 9 times the square root of x plus 3. Okay, and now we can just cancel these out. So this will just be 1 over what just happened? So yeah, we get 1 over the root x plus 3. And now we can just substitute 9 into the equation. So if we substitute, so if we substitute 9, we'd get 1 over 6. So the answer for this question is 1 over 6. Okay. Let's move on to the next question. So I'm moving on to trigonometry now. So what is the limit? I'm not going to make you do this question, though, and I'll tell you why. As x approaches 0 of sine x over x. And the reason I didn't want you to do this question is you should memorize this. This just equals 1. So hopefully you should memorize this, as for any limit, this would just approach 1. Okay, so yeah, just memorize that. Now let's move on to the next question. What is the limit as x approaches 1 of x cubed minus 1 over x minus 1? So take like 2 minutes to solve this question. So pause the video and solve. Okay, hopefully you've paused the video and you've solved. So if we substitute in this, we'd see that we'd get 0 over 0. So we have to factor. Okay. So we have this. So we can factor the top and we get so x squared plus x plus 1. Yeah, and then the bottom would be x minus 1. So we factored that out. Now we can factor these two terms out. So cancel. In the end, we'd get x squared plus x. Actually, it's too much work. It's gonna. Yeah. So we get x squared plus x plus 1, and now we substitute. The value we're substituting is, of course, what the limit is approaching. So we're going to be substituting x equals 1. So 1 squared plus 1 plus 1 equals 3. So this equals 3. So the limit for this question is 3. Okay. So those are going to be our example problems. And now for our challenge problems. So I'm going to be giving you questions, and 5 questions, and you have to solve them by yourself, and then I'll give you the answer in the video. Let's think of some questions. What is the limit as x approaches 5 of the function x squared minus 25 over x minus 5? That's question 1. Time for question 2. What is the limit as x approaches 4 of x minus 4, the square root of x minus 2 over x minus 4? So that's your second question. Third question. Ooh, I was thinking about doing another trigonometry question. That, yeah, that's probably for another video. Yeah, that question would be too hard for this video. Yeah, we're only doing, okay, so what is the limit as x approaches 2 of x squared plus x minus 6 over x minus 2? And then, so final question. Okay, for question 4, I'm just going to teach you how to do it. So, what is the limit as x approaches 0 tangent x over x? So, yeah. And for our last question, let's do something easy for a cool down. What is the limit as x approaches 0 of x? So yeah, do those questions. You can pause the video, and I'm going to be answering them. Okay, hopefully you're done. You've unpaused the video. So I'm going to be writing down the answers. So this question should equal 10. This should equal 1 over 4. This should equal, wait, that does equal 1 over 4, right? Yeah, that does. This should equal 5. This should equal 1. and this should just equal 0. So compare your work with these answers, and you can just skip to, if you got a question wrong, you can just skip to that part. And if you got all the questions right, you don't have to watch the rest because you got it. Okay. Time to explain each question. Okay, first one. So if we plug in 5 into the question, we'd see that we'd get 0 over 0. So that is an indeterminate form. So what we have to do is... So the top is, if we factor that out, that's x plus 5 and x minus 5. And x at the bottom is x minus 5. So if we cancel out the common factors, we'd be left with x plus 5. And now we sub in our limit. So our limit was as x approaches 5. So if we substitute 5, this is going to be writing sub x equal to 5. We get 5 plus 5 equals, which would equal 10. So yeah, that's the answer. On to the next question. What is the limit of x as it approaches 4 of the square root of x minus 2 over x minus 4? And the answer should have been 1 over 4. Okay, let's do this. So same method as before, we're going to be multiplying the top and bottom by the conjugate. So I'm going to be multiplying the conjugate in red, so it makes it more obvious. So the square root of x plus 3 over the square root of x plus 3. So simplifying the numerator, we would get x minus 4 over so the square root of x plus 2. And now we cross those out. So this would equal 1 over square root of x plus 2. And now if we sub in 2, not 2, if we sub in 4, sub x equals 4, we'd get 1 over 2 plus 2. So 1 over 4. And I forgot the equal signs for everything. Yeah, so this is here. On to the next question. Hang on, I need to put all of these away. So for this question, you should have gotten I forgot, this should say 2. Dude, sorry about that. What is the limit as x approaches 2 of x squared plus x minus 6 over x minus 2 equals 5? You should have gotten that it equals 5. So if we plug into our equation, we would get 0 over 0, which is indeterminate. So what we have to do is factor the numerator. So if we factor out the top, we get x plus 3 times x minus 2 over x minus 2. And now we have to cross these values out. And x plus 3 if we sub in so if we sub in what was it, sub in 2, x equals 2, we get 2 plus 3 equals 5. So our answer equals 5. Yeah, and that's it for that question. And time for the harder one. So if you got this question wrong, it's okay. So hopefully you know what trigonometry is and you've taken trigonometry. So okay. So I'm gonna be doing steps across. So this isn't gonna be actually part of the problem. But 10x equals sine x over cos x. So think about for a minute how you could use that and how you could use that in this question. Okay, so hopefully you've thought about it. So basically, since we know this, we can transform this equation into sine, because of that, tan x over x equals sine x over x times cos x. So now we just separate the factors so that this would be sine x over x times 1 over cos x, and there's also there's two trigonometric limits that you should just know, and that is limit, I already said this before, but the limit as x approaches 0 of sine x over x is equal to 1. You should memorize that. And the limit as x approaches cos x is also equal to 1. So memorize that. So using that, we substitute and we get 1 times 1 over 1, which equals 1. So our answer is just 1. So yeah, that's a hard question. And that shouldn't really be that easy for you guys. I'm going to be doing another video on limits on trigonometric values, so stay in tune for that. And finally, we can just, for this question, just plug in x into the equation. So what is 0? That's just 0. So yeah, those are all the questions. I also have a derivative video if you want to watch that, which goes over the power rule and application and everything. So if you want to watch that video, you can watch that. But otherwise, thank you for watching.